Okay, so you should have had enough time to work through 2 through 16, working with expanding the logarithm, and now we're going to do each of these examples backwards. So instead of expanding them, we're taking a fully expanded logarithm and we're condensing it down. So on the same handout, number 17, if I have 4 times the log base 6 of 11, then using the power property in reverse, then I can take this coefficient and make it the exponent of my 11. So this is going to be log base 6 of 11 to the 4th power. And then for number 19, if I have log base 5 of 11, then this is already fully condensed and we can't do anything with it. So it just is what it is. For 21, we have 5 times log base 4 of 10 minus 4 times log base 4 of 11. So the first thing I'm going to do is I need to rewrite each part of this expression using the power property. So this is going to become log base 4 of 10 to the 5th power minus log base 4 of 11 to the 4th power. And then using the quotient property, since I'm subtracting these two, that means I'm actually going to be dividing them within the same log. So these can then be further combined as log base 4 of 10 to the 5th over 11 to the 4th. For number 23, we have 2 times log base 2 of 10 plus log base 2 of 7 plus log base 2 of 11 over 2. Okay, so I'm going to take the time to rewrite each one of these using the power property. So I start off with the very first thing I'm going to do is I'm going to rewrite this one so that what we're looking at is this becomes log base 2 of 10 squared. And log base 2 of 7 doesn't change, it just is. Well, this divided by 2 actually means multiplied by 1/2. So I have 1/2 times the log base 2 of 11. So I'm going to further simplify this down and condense it so that I have log base 2 of 10 squared plus log base 2 of 7 plus log base 2 of 11 raised to the 1/2 power. Well, that 1/2 power actually means the square root. So this is log base 2 of 10 squared plus log base 2 of 7 plus log base 2 of the square root of 11. And then since I'm adding all of these together, I can use the product property, and this becomes log base 2 of 10 squared times 7 times the square root of 11. For number 25, we have log base 8 of a over 2, very similar to the last term in number 23 above it. This actually means 1/2 times the log base 8 of a. And using the power property, this is log base 8 of a to the 1/2 power, which means the square root. So this is log base 8 of the square root of a. For number 27, we have 2 times log base 7 of x plus 2 times log base 7 of y. So using the power property, this becomes log base 7 of x squared plus log base 7 of y squared, and it becomes log base 7 of x squared times y squared. For 29, we have 2 times log base 5 of x plus 3 times log base 5 of y is equal to log base 5 of x squared plus log base 5 of y cubed. And using the product property, this is log base 5 of x squared times y cubed. And then for 31, we have 4 times log base 5 of x minus log base 5 of z minus 6 times log base 5 of y. So this is, since we're subtracting all of them, that means we're actually going to be dividing. So if I start by dividing these two by making this x to the 4th, then I'm going to have log base 5 of x to the 4th divided by z minus log base 5 of y to the 6th. Well, that means I have to divide this whole thing by y to the 6th, which means I'm going to have both z and y to the 6th in the denominator of my quotient. So when I rewrite this, this becomes log base 5 of x to the 4th over y to the 6th times z. So these examples are going to coincide with numbers 18 through 32 on the handout that was given to you. Spend some time and work through those examples, and the homework for tonight will directly correlate to each of these examples that we worked in class today. I am available after school today. If you should have any questions, come see me. If not, you will have more videos again tomorrow.